Hi, 7th grade. Welcome to lesson 2-3. Understand proportional relationships, equivalent ratios. By the end of today's lesson, I want you to be able to say, I can test for equivalent ratios to decide whether quantities are in a proportional relationship. Let's solve and discuss it. Weight is a measure of force affected by gravity. The moon's gravity is less than the Earth's gravity, so objects weigh less on the moon than they do on Earth. Using the information provided, how much do you think a cat will weigh on the moon? Explain your reasoning. Pause the video, write down something that you think, a thought, a number, and we will discuss it. Okay, so my thought process is the fact that whether we are on the Earth or the moon, the cat is going to weigh more than the rabbit and less than the dog. So if you said any number between 0.75 and 15 pounds, I would have to agree with you. Focus on math practices. How could you find the approximate weight of any object on the moon? Explain your reasoning. Well, we can find what's called the constant of proportionality. That's one of your vocab words, and we're going to talk about it a lot today. The constant is a number of proportionality. Which just means we are going to find how many times more or less something weighs on the moon than the Earth. And the way we can do that is by setting up a ratio. The dog weighs 15 pounds on the moon, and he weighs 90 pounds on Earth. So if we reduce that, 15 over 90, it gives us 1/6. That means the weight is 1/6 times less than it is, the weight is 1/6 of the weight on your Earth. Example 1. On Sarah's favorite mobile game, she's awarded game lives when she finds gold coins. How is the number of game lives awarded related to the number of gold coins found? Well, I'm looking at her 3 different screens here. Okay, this first screen, she has 3 gold coins. 1, 2, 3. They show that here, 3 gold coins and 9 hearts, 9 lives. So that gives me 3/9. On the second screen, she has 2 gold coins and 6 red hearts, which gives me 2 out of 6. And on the last screen, she gives me 5 gold coins and 15 red hearts. So if we're looking at the coins and game lives in this nice chart, we can see that each of them, when we divide the coins by the game lives, reduce to 1/3. So that means since they all have the same number, when you divide, it is a proportional relationship. Here is one of your vocab words. 2 quantities in a proportional relationship. Two quantities are in a proportional relationship if all of the ratios that relate the quantities are equivalent. Okay, so equivalent meaning equal, ratios meaning we divided. So each ratio is coins to game lives is equivalent to 1/3. The number of game lives awarded is proportional to the number of gold coins found. Let's try it. Miles records the time it takes to download a variety of file types. How is the downloaded time related to the file size? Explain. Okay, so they give us the file size and the download time and tell us that the ratio is downloaded time divided by file size. So we take 25 and divide it by 1.25. If we do that, we should get an answer of 20. Now we'll do it for the songs. If we take 72 songs, because remember you put the download time on top. 72 divided by 3.6, again we get 20. And last but not least, 125 divided by 6.25, we get 20. The whole time, this is the x, the independent variable, and this is the y, the dependent variable. Whenever we're finding our ratio, we always do y divided by x. So the ratios for each pair of data are 20. So the download time and the file size are proportional. Okay, so how can you show that two quantities have a proportional relationship? By showing their constant of proportionality are equivalent. Example number 2, decide whether quantities are proportional. Is this relationship between the area and the side length of the squares proportional? Explain your reasoning. Okay, so remember, side length is 2. If the side length of a square is 2, the area is going to be 4 because area equals length times width. And in a square, the length and the width are the same. So 2 times 2 equals 4, 3 times 3 equals 9, 4 times 4 equals 6. We're looking for this constant of proportionality here. So that's the constant of proportionality. Remember, I told you it's y divided by x. So they do 4 divided by 2 and get 2 over 1. 9 divided by 3 and get 3 over 1. 16 divided by 4 and get 4 over 1. Is the constant of proportionality the same for all 3 squares? No. So since that's not the same, the ratios are not equivalent, so the relationship between area and side length is not proportional. Try it. The table at the right shows information about regular hexagons. Is the relationship between perimeter and the side length of the hexagons proportional? Explain. So I'm going to put this extra box here, and this is where we do our y divided by x. So I want you to try this on your own. Pause the video and check back to check your answers. All right, when I do y divided by x, 12 divided by 2 equals 6, and 18 divided by 3 also equals 6. Since the constant of proportionality, the ratios are the same, they are proportional. So yes, the ratios are equal. Example number 3. Use proportions to solve problems. Here's another vocab word. A proportion is an equation that represents equal ratios. Use the table at the right. How many times will a hummingbird beat its wings in 60 seconds? So the first thing we have to do is make sure that these are proportional. So we do our y divided by x. So they did it over here for us in step 1. They saw 60 divided by 2 is 80. 560 divided by 7, again, is 80. And 800 divided by 10 is 80. So sweet. It's a proportional relationship. Only if you have a proportional relationship can you write an equal ratio. So we know that it beats 80 beats per second. We want to know what's going to happen in 60 seconds. So the top is beats. If I make this bigger. Nope, it's not working for me here. The top is beats. And the bottom is seconds. Okay? We are trying to figure out how many times in 60 seconds. So that's how you know 60 has to go on the bottom. We are trying to solve for y. Right now, y is being divided by 60. So that's why you multiply by 60 on both sides. It cancels out over here. We do 80 times 60 is 4,800. So a hummingbird beats its wings 4,800 times in 60 seconds. Let's try it. Ginny's favorite cookie recipe requires 1.5 cups of sugar to make 24 cookies. How much sugar does Ginny need to make 36 of these cookies? So if we have 1.5 cups, I'm sorry, you guys should pause this, try it on your own. Press play when you want to try it. Press play when you want to check your work. All right, so if we have 1.5 cups of sugar with 24 cookies. And we want an equivalent ratio with 36 cookies. Well, I'm trying to find how many cups. So in order to get the C by itself, right now it's being divided by 36. So we're going to multiply both sides by 36. So I have 36 over 1 times 1.5 over 24. So I'm going to do 36. Hello. Sorry, my calculator's not working. 36 times 1.5, which equals 54, divided by 24, equals 2.25. So we'll need 2.25 cups of sugar to make the cookies. On the next page, the key concept. Two quantities x and y have a proportional relationship if all the ratios y divided by x for the related pairs of x and y are equivalent. Remember, I mentioned that this y divided by x is called the constant of proportionality. So here they show us y divided by x. 3 divided by 120 is 0.025. 5 divided by 200 is 0.025. So the ratios are equivalent, meaning they are proportional. All right, 7th grade, let's say it. I can test for equivalent ratios to decide whether quantities are in a proportional relationship. Have a great day.